I'd like to introduce Mr. Preetesh Singh. Mr. Singh is a senior member at Automotive Industry Consulting Group, NRI Consulting and Solutions India Private Limited. He has been conducting strategy and operational consulting assignments for global automotive OEMs, suppliers, and R&D organizations and government. Mr. Singh has over a decade of experience in studying different themes related to technology, automotive, and energy. One of the focus areas has been electric vehicles for Indian and global markets. Today, Mr. Singh will talk on metal forming in digital age and exploring the impact of Industry 4.0. So without further ado, let's welcome Mr. Singh.
Thank you very much, Darshana. Thank you very much, OEM Update, for organizing such an amazing discussion, such an amazing topic of the discussion and introducing this, and also giving me the opportunity to talk about our viewpoints about the subject. So, initial 10 minutes, I'm going to make the presentation around metal forming in the digital age, exploring the impact of Industry 4.0. And we have several experts from the industry who have deeper knowledge around working on these technologies on floor or in real situations. So I think they can give more deeper insights. So I would like to touch upon different topics which are emerging around this theme, and then we can deep dive through other speakers. And in the end, I hope to have a very good Q&A round. Let me briefly talk about the metal forming processes which are currently there. So there are two types of metal forming processes which are commonly known, which is one is the bulk metal operations, and the second what we have is in terms of sheet metal operations. So in bulk metal operations, operations are majorly commonly understood are forging, extrusion, and rolling. And when it comes to this sheet metal operations, we have drawing, bending, shearing, etc. And in this, stamping involves basic operations as well as flanging, punching, etc., depending on the applications. I will try to connect this to the automotive industry because sheet metal operations find a lot of use cases in automotive industry. So in auto applications, if you look at on the right-hand side of the slide, you'll find dashboard, panels, fuel tanks, chassis components, wheel rims, just to name a few. There are many more applications of these sheet metal operations around the automotive industry. The typical processes are die design, simulation, blanking, drawing, trimming, flanging, and finishing. And let me talk about die designing and simulation because a lot of innovation has happened around this to improve the efficiency, reduce the time, etc. So it is done with CNC machining with additive hybrid manufacturing for making dies. And blanking is mostly CNC laser cutting, water jet cutting are commonly used as alternate. Moving on, after talking about the basics of the metal forming, which I talked in terms of bulk metal operations and sheet metal operations, let me briefly talk about how automotive industry or the automotive component industry in general is performing. If you look at the historical data, approximately $75 billion industry. And if you divide this into engine parts, drive transmission, electrical, electronics, suspension, braking, body and chassis, accessories, and miscellaneous, the body and chassis is approximately 12% of the entire market, and which is like dominated by engine parts, 27%. But body and chassis, why I'm highlighting is that this is one of the major dependency on the sheet metal. So with the growth of automotive industry, sheet metal forming industry in India is also very strongly, growing because of the growth of the automotive component industry. And I think we have almost regained pre-COVID era in the automotive industry. If you look at the component industry growth, it's more than 25% from FY21 to 23, 22, and 23 also is kind of similar case. And majorly because a lot of interventions has happened from the government of India side, including PLI scheme. So with this sheet metal playing to a major role in body and chassis, which is 12% of the total market, hence growth of agnostic of alternate powertrain transitions. So we can expect a very good momentum of metal forming in this as well. Let me briefly talk about the entire mega trends in manufacturing. So if you look at the mega trends in manufacturing, you'll find Industry 4.0, which is Indian manufacturing sector, which is, is spending approximately 6 billion over Industry 4.0 technologies like IoT, AI, ML, cloud, cybersecurity, AR, VR, etc. Second, mega trend is in terms of sustainability. I think India as a nation and also globally, mostly we are talking about sustainability. So a lot of opportunity in different sectors are emerging, and the metal forming is also not the one of the exceptions. So increased adoption of carbon investments, captive REI to offset emissions, and anything related to sustainability is a big theme. Then the additive and hybrid manufacturing. So India additive manufacturing is approximately $100 million industry in 2022. And then one more common trend is China plus one sourcing strategy. So whether India finds a way for that plus one strategy or not is a debatable question, but obviously every manufacturer or major economies globally are looking for China plus one sourcing strategy because of the kind of threat we have seen during the pandemic era. Now, moving on, let me talk about some of the use cases which are very, very important related to IoT or the Industry 4.0 technologies. Majority of the technologies, as I already mentioned, are AI, ML, cloud, augmented reality, digital twins in some of the cases. These are the majority of the technologies related to Industry 4.0. If I divide this into upstream supply, planning, production operations, and logistics and downstream, then we can have a look on the different use cases which are emerging around these part of the value chain. So for example, let me start with the upstream supply chain. Your real-time order management is really one of the very unique example in which integration of IIoT and MES SCADA happens. And then the sourcing and supplier performance monitoring. For example, you will find a lot of sourcing related solutions, or the reality is sourcing is not integrated. So you can't really take the real-time decisions. Sometimes it's based on, historical understanding, the experience of the people who are deployed there. But this becomes a very unique example in which you do the predictions of suppliers by judging their financial stability metrics. You can be defined in many ways and find out the supplier, alternate supplier, and it can suggest automatically. So these are some of the use cases which are finding its implementation. In terms of planning, predictive planning and scheduling. So in predictive planning and scheduling, even traceability through data from edge sensors can be utilized, like plus cloud data. So the real-time planning and scheduling is one of the unique examples what we can see in terms of the Industry 4.0 technologies. Moving on in terms of production operations, it's smart machines, smart line operations, in which you can see self-optimizing or the balancing. So different manufacturing lines can be properly utilized in the production operations if you deploy the technologies like what I have mentioned in terms of edge, machine learning, IoT, digital twins, and AR. Similar examples are also in logistics and downstream, very similar to what I talked about in upstream supply chain. Like you can have smart warehouses for storage and the predictive logistics. Moving on, let me briefly talk about CNC metal forming processes and IoT impact. In conventional flow in SMEs mostly, the basic simulations are happening. Based on the basic simulation, you do the die design using different parameters, and you do this several times before you arrive on a conclusion. So it's a repetitive process, time-taking process, and it costs a lot of money. But the impact of Industry 4.0 technologies can be generative AI for die design, in which we can have digital twin inputs of machine, and we can actually make the adjustment, and eventually the outcome of this can be the first time right, which is the target of any component manufacturer eventually. I think we have companies, we have Mr. Daniel also, who will talk about solutions around these in detail. Then moving on the raw material sourcing, we have been doing this ad hoc need basis. And if industry adopts this as a mass scale, then machines can ensure by sensing the utilization and dynamically placing the order based on the demand. So we really don't need to depend on experience basis or ad hoc need basis. Has to be can change by deploying the AI powered green solutions using AI technologies. Then in the last, production and shipping, the scheduled maintenance, internal suboptimal heuristics. Again, it's all experiential, based on experience. So moving for the smart machine coordination, operations, etc., we can improve a lot of efficiency here as well. Now, because in the beginning, I also talked about emergence of different alternate powertrains, including CNG, ethanol, methanol, flex fuel, and electrification. All the electric vehicles are finding the largest the implementation nowadays. So let me briefly talk about CNC metal forming processes adoption for the EV manufacturing, which can be one of the unique ways to look at this industry. Is like, if you look at in terms of EV manufacturing, so on left hand side you will see the battery manufacturing, battery enclosures, motor laminators, and overall light weighting of sheet metal body parts are the most key areas. In battery closures, advanced cooling requires integrating topology, optimized structures with manufacturing and advanced material considerations, which in turn pushes for increased integration of machine learning for CNC forming manufacturing simulations. Now, in terms of laminates, other motor components, EVs would demand even higher traceability requirements, and which eventually requires integration of IIoT in CNC forming. Just to conclude, overall, lightweighting would also lead to exploration around lighter and advanced materials, so that the sheet metal parts, which are key, which are likely to push boundary of CNC metal forming technology. So these are the three areas: battery enclosures, motor, housing shaft, overall lightweighting trends in electrification are going to generate newer demands, or you can say the additional demands, which can also be the part of the replacement one. But in this also, there is a lot of implementation of Industry 4.0 technologies to make it more efficient, because that is how the new alternate powertrain, including electrification in India, is being defined. So that is all what I have today. Thank you very much.
Thank you, Mr. Singh, for talking about metal forming in digital age and exploring the impact of Industry 4.0.